Welcome to the 4.3 notes. Today we are going to be talking about something called synthetic division. Synthetic division is a special type of division that can only be used if you are dividing by what's called x minus a. And what that means is it's x and a number, but not anything else. There's no x squared here, and there's no number in front of x. So it just has to be x and a number. And I have it as minus here for a reason. Um, what I want to go over before we start is like synthetic means that it's something artificial or made of artificial material, not natural material. So this isn't going to be as natural as the division we talked about in 4.2. It is going to be almost like a shortcut. Okay, and this shortcut may or may not make sense to you. This section is either going to be your best friend or your worst enemy. It's going to be your best friend if you are able to move past the fact that we won't really understand why the steps we're doing work, and if we just focus on doing those steps. It's going to be your worst enemy if you get too hung up on the why. Okay, if you move on and don't worry about the why, it'll be your best friend. Okay, um, and there are a couple of theorems here. I'm not going to talk about them just yet. I'm going to come back to these two. But I will say this third thing is that we can use synthetic division to help factor polynomials. And that's one of the goals of dividing. I talked to you guys about that in 4.2 also. And that's something that's kind of new to us is by dividing, we are also learning how to factor still. So it kind of helps us factor things that weren't normally factorable. So what you're going to do for synthetic division is you're going to put the value of a in the corner with like a little box around it like this. Now, you might be like, that's a -4 though, Mrs. McFadden. It is, but see how it's x minus a? That means that a is the opposite of this number, okay? That is really annoying, so I'm gonna get it to stop doing that, okay? And then what you're gonna do afterwards is you're gonna take this and write it right here, but you're not gonna include any of the variables. So just the coefficients. Like x squared has a 1 in front of it, 8, or x has an 8 in front of it, and there's a 1 at the end. So just the numbers. Almost like we did when we were doing matrices. It's kind of similar to that. And then this is the part where it gets a little strange. And I'm going to write a little note about this in just a second, but this number is going to come straight down. And then you are going to do two things. You are going to multiply across, and then you are going to add down. Now, right now, those two things don't make any sense to you, but they will in just a second. What I mean by multiply across is you want to multiply these two numbers together. And I'm only going to draw these arrows the first time. I'm not going to draw them again. So you're going to multiply these two numbers. And you are going to write your answer right here. And then you are going to add these two things together. And then you are going to multiply these two numbers. And put your answer right here. And then you're going to add those two numbers. So whatever new number is right here, that's the one that gets multiplied by this. Write your answer on the next column, and you add them together. And then you're going to put another little box, kind of like this one, on this right here. Because this is your remainder. And how we write our answer is you start next to this box right here. This is going to be your regular number. And then you're going to go up a power of x. So this will be x. And if there were more things, we would move on to x squared, x cubed, x to the fourth. So you have 1x plus 12. No, you do not have to write the 1 in front of that x. And then you have to add the remainder. And from 4.2, the way that you write the remainder for a division problem is it goes on top, and whatever you were dividing by goes on bottom. So x minus 4 goes on the bottom. Just like if you were dividing something by 4 and you had a remainder of 3, that would be 3/4. Since 4 is the thing you were dividing by, same kind of thing happens here. And that's your answer. This, again, is one of those things that makes a lot more sense out of the first 2 or 3 examples. So I'm going to keep moving to the next one, and then I'll explain what those two theorems are. So right here, this would have to be x minus -5 in order to become a plus 5. It has to start off as subtraction because of this. So -5 is the number that's going to go right here. And then I have 2x squared, -1x, and 7. And then this first number comes straight down because it doesn't have anything to add to yet. So that's why 8 just goes straight down. And then you're going to multiply across. That's going to be -10 and add down. Multiply across. That's 55. Add down. And then this is your remainder. And I'm just going to write that. I get tired of writing out remainder, so I just write R. So this will be the number, this will be x, and if I had to keep going, I would do x squared, x cubed, x to the fourth, in order. Okay, and then plus the 62 over x plus 5. Because you take your remainder and write it over the thing that we were dividing by, over the denominator that was already up there. Okay. Over here, x plus 5 is the same thing, so you're still going to have a -5 out front. The part that's different about this third one is it's got different coefficients and more coefficients. And then one, like red alert, is there are no x squareds right here. So get really used to checking your powers and making sure they go in order. Just like these go in the opposite order, these have to go in the correct order in the beginning. X to the fourth, x cubed, there's no x squareds here in the middle. So that's where you need a 0 placeholder. Keep a very sharp eye out for those. In fact, what some people did on 4.2 is they looked for all of those first and didn't try any problem until they had looked through the entire assignment for those. They are tricky and easy to miss, so be on the lookout for them. Okay, now I'm going to say that this one freaks people out because it's long. Just relax, take it one step at a time. After you get these written out, it's actually pretty easy. This number comes down, and you're just going to get in this rhythm of multiplying across and adding down. So multiply across, add down. Multiply across, add down. Multiply across, add down. Multiply across, add down. The last one is always your remainder. So that really wasn't that crazy. It's actually pretty easy still. It did take a few more steps, but they're not that difficult. And then this is going to be your constant, your x squared, and your x cubed. So this one does have more terms in its answer. So this is going to be x cubed minus x squared plus 5x minus 9, and then the remainder of 10 over x plus 5. Long answer? Sure. But a difficult problem? No, not really. The hardest part you did was -5 times -9, guys. And that was 45. Okay, let's talk about factoring. So we did this in the last assignment too. If your remainder is 0, so your remainder must equal 0, okay? And then it's a factor and you can use your answer to factor it. I'm gonna take just a second, pause, come back up to the top. If you divide by this, it is a factor of the polynomial if the remainder is 0. So there was an example at the end of the 4.2 assignment where the remainder wasn't 0. It didn't work out properly, so it wasn't a factor. Okay. So we want this to be a factor. That means we're going to divide by it, like that. And then the -1 is going to go here, and you're going to copy down all of those coefficients. -3, -6, 33, 36. And then here's the really funky thing about this one. Its 0 placeholders go at the end. There's no x's and there's no constant. The question I get asked a lot is, do I still need those? Yes, because if we don't add these two, then when I go back to put in my x squared, x cubed, everything's going to have the wrong power if I don't put these extra columns in there. That's really the only reason why. The only reason why we ever need those 0 placeholders is to keep our powers lined up correctly. All right, now drop that first number, and we're going to fall into that rhythm of multiplying across and adding down. Multiplying across, 3. -6 plus 3 is -3. -3 times -1 is 3. 33 plus 3 is 36. 36 times -1 is -36. 36 minus 36 is 0. Finally, -1 times 0 is 0. 0 plus 0 is 0. -1 times 0 is 0. 0 plus 0 is 0. That's my remainder. If this wasn't 0, we would have a problem. And then this is my number, x squared, x cubed, x to the 4th. So we have -3 x to the 4th minus 3x cubed plus 36x squared. Now, that would be your answer if we were doing it like these up here. Notice how we don't have to add the little part at the end, the fraction like this, because it was 0. If it asks you to factor, what you need to do is take your answer, put it in parentheses, and put whatever you were dividing by at the end. Because since this divided by x plus 1 is this times the thing you were dividing by equals the original. So this is the factored form. And I'm not going to because I really don't want to, but if I were to multiply this back out, I would get back to this. And I wouldn't do that if I hadn't fixed these powers by having these extra 2 zeros there. All right. I'm gonna do one more, but I'm gonna go through this one a lot faster. You don't need to write that you're dividing like that, but all you really need to do is take the opposite of this number in the parentheses, which would be 2. I think of that like the 0. It's whatever number makes this parentheses 0, kind of like we did last unit. So 2 minus 2 is 0, that's what goes right here. And then here's my coefficients, 16, 16, -105, -9, and 54. There are no 0 placeholders on this one. Drop it down. 16 times 2 is 32. 32 plus 16 is 48. Now, we do get a little sticky here for a second. 48 times 2 is 96. 105 plus 96 is negative 9. Negative 9 times 2 is negative 18. Negative 9 plus negative 18 is negative 27. And negative 27 times 2, thank goodness, is negative 54. Number x squared, x cubed. 16x cubed plus 48x squared minus 9x minus 27. No little fraction because my remainder was 0, which would be a problem if it said it was a factor. It's lying to you otherwise, just like I lied to you on one problem on the last homework. And then you add the thing that you were dividing by as the other factor. Remember that when we're factoring something, we usually do want 2 sets of parentheses. It just didn't look quite this crazy last unit. And this one's my favorite because this is actually something really cool and somewhat useful. Would you ever remember to do this on your own outside of this? Probably not. But you can use synthetic division and the remainder theorem to evaluate a function. Just a reminder that when we say things like this, we want to be plugging -1 in for x in both spots. The thing is, with polynomials, when you're cubing and taking things to the fourth power and dealing with negatives, it can get really confusing to do yourself. It's not a very difficult topic, but the negatives can get kind of tricky. So what we're going to do, and I'm going to scroll back up, is use the remainder theorem. So if the remainder of f of x divided by x minus a, so same kind of thing we were just doing, is a number, I'm going to call it b, then the value of the function at that value is b. So basically, if you make this number go in the little box, and notice how I did not change the number this time, because really we're trying to divide by x plus 1, because that would be the factor if -1 was a 0. And we're going to plug in the coefficients now. So basically, if there's no x with it, you don't have to change the sign. Drop the first one down, multiply across. -1 times -1 is 1. Add down. Why do I feel like I forgot something? Nope, I didn't. -8 plus 1 is -7. -1 times -7 is 7. And that's your remainder. So f of -1 is 37. Just to prove to you that this does work, if I plug this -1 back in to my calculator, it would be -1 squared minus 8 times -1 plus 30. That's 37. But look at all those negatives. Like, that was actually kind of difficult just to type into my calculator because you have to do -1 squared. That's 1 times -1. That's -1 minus 8 times -1 plus 30. Like, that's not entirely difficult, but there's a lot going on there. This was so easy. I just did a little bit of multiplication and bam, there's my answer. And that's one of the coolest things that synthetic division can do. Now I'm going to take the 2 and plug it in. Okay, 1, -2, 4, 3. No 0 placeholders because it didn't skip any powers. The thing about this one is you would have to do 2 cubed minus 2 times 2 squared plus 4 times 2 plus 3, which just sounds complicated. Instead, we can just plug this on in. 2 times 1 is 2. -2 plus 2 is 0. 0 times 2 is 0. 4 plus 0 is 4. 4 times 2 is 8. 8 plus 3 is 11. I forgot to circle my answer over there.